Okay, so this is a whole section on inverse functions. It's going to be completely different than what we've been doing, but that different doesn't mean more difficult. So I do think this is a pretty easy section. If you're struggling with all the other sections we've been doing, this might be a nice section to just bridge the gap and get some extra little points on the test on Tuesday. So I'm just going to go through one problem from each section because they're slightly different each time. And then from there, you guys are going to finish this by the end of the hour. So number one, they're asking us to find the inverse of each relation. The relation is just a set of ordered pairs that we learned in the notes. And so when you find the inverse is just simply taking the xy and rewriting it as y comma x. The signs stay the same, they just change where they're at. So in this first one right here, we're going to have, instead of negative 9, 1, we're going to rewrite that as negative 1, negative 9. Negative 7, negative 4 becomes negative 4, negative 7. Negative 7, negative 5. Negative 10, negative 3. I know I'm going into my other spaces, just writing large, so try to keep it all in that little space below the problem. And then the last one would be negative 13, negative 1. There is your inverse function. Just put the little brackets around it. And there's your inverse. Okay, I flip-flopped all of the x's and y's. Okay, number 4, same concept. It's just not in a table. It's in set builder notation. So instead of negative 3 and 2, we're going to have 2, negative 3. Instead of the ordered pair negative 1, 8, we're going to have 8, negative 1, 14 and 1, and 20 and 3. That is what an inverse is. All the ordered pairs, the x is your y and your y is your x. Come down to the graph. They want us to graph the inverse function. Well, in order to graph the inverse function, I kind of need to know what the original function is. So they're giving us, this is the original function right here. Okay, so that's the function that they gave us. So I'm just going to call that f of x. That's the function. And let's just get a table of values so I know from that what I can graph with. So I can see a couple ordered pairs. I see this nice ordered pair, 0, negative 4 is on that regular function. I also see this ordered pair here. Just look for the little cross marks. That would be 4, negative 1. And then I'm going to get one more to help us out here. I'm going to move my red line though, because I feel like you don't want to use these points where it's not hitting somewhere, but it looks like over here we're hitting right at that corner. That would be negative 9, negative 8, looks like. So you want to make sure it's hitting the actual spot or the arrowhead is going right through that ordered pair. So those are the ones I thought were pretty nice. I got 3 of them. So now what I'm going to do is I'm going to write the inverse function. So in the notes, I denoted that little notation. Anything raised to the negative 1 power, we say is the inverse. So this is saying the inverse of f of x. Okay, and so a table of values, all of your x's become your y's. So in this ordered pair, 0, negative 4, I'm going to graph negative 4, 0. On the original graph, 4, negative 1, on the inverse, negative 1, 4 exists. And if on the original, negative 9, negative 8, well then on the inverse, negative 8, negative 9 will exist. So when I graph these and connect them, negative 4, 0 is an x-intercept now. Negative 1, 4 comes up here. And negative 8, negative 9 is down here. When I connect and extend those, one of the things that should happen is a 45 degree. Now 45 degrees is just that little, it cuts right through here, 0, 0, 1, 1. This should cut right through the 2. So it's like a line of symmetry. That's an easy way to check. I put my little symmetrical line in there, that 45 degree from one corner to the other, upper right to upper left. And if I folded on that black dotted line, the red, all the parts of red would fold onto green. So it's a nice, easy way to check your answer. Okay, so do the same thing with number 9 and number 10. Just looking at 9 and 10, I could probably point out a couple of the ordered pairs. I'm not naming them for you, but this looks like a nice spot. This looks like a nice one to use, and same with that one. And for number 10, it looks like, let's see, this looks like a nice ordered pair to use. This looks like a nice ordered pair to use, and stay right where that arrowhead is pointing. So use those 3 ordered pairs. I mean, you can use what you want, but it doesn't look like they give you a whole lot of options because it's not crisscrossing. All right, so you're going to do the same thing. You're going to make a table of values and then reverse it and graph it. On the back side, This is probably the hardest part, but it really isn't too difficult if you follow the steps that I provided. Okay, so I'll do number 11 with you, and then I'll pick another one in here to do with you. Number 11, f of x equals 8x minus 5. So the first thing we have to do is just change f of x into a y. Bring the y value into the equation. And then that way, I don't know why that's not going away. F of x is just fancy for y. So now what I'm going to do is interchange, just like we did on the graphs, just like we did in the table. We just interchange x and y. So everything else stays. Signs stay, numbers stay. So this would become x equals 8y minus 5. Okay, and now all we have to do is rewrite it in terms of y. So now we got to solve for this y value. And so to solve for that y value right now, that y is being multiplied by 8 and subtracting 5. So I'm going to take care of the subtraction of 5 first. I'm going to add 5 to both sides. We've done this many times, guys, when we switch to standard form and all that good stuff. We're just solving for y. I don't care if you put the 5 out in front of x, or I know you guys have kind of been trained to put x in front of 5. It doesn't matter when you're writing inverses. Equals 8y. And then the divide by 8, you can simply just divide this whole side by 8 and leave it alone. Okay, so my final answer would be y is equal to x plus 5 over 8. And then the last thing we do is we just fancy up our y, and we call it inverse function is equal to x plus 5 over 8. I kind of switched the sides on you there, but that's really the best way to write that. So I kind of flip-flopped it, and then instead of writing y, we just brought back in the fancy terminology for function. And there it is. You are allowed, if you need to divide those out. So you could have divided the x by 8 and then the 5 by 8, kind of separate it, divide both of these by 8 and give this answer as well. Sometimes, you know, if it's multiple choice, you got to be able to understand that they're both saying the same thing there. Let's do 13, with a fraction here. So again, I'm going to bring in the y, flip-flop x and y. And now solve for y. So y is being multiplied by 3/4, and we're adding 9. So I'm going to take care of the addition of 9 first. To get rid of it, I'm going to subtract 9 from both sides. I'm going to let the x go out in front. X minus 9 equals 3/4 y. If you're multiplying by 3/4, another way to look at that is multiply by 4/3. So if I multiply by 4/3, both sides, this whole side gets multiplied by 4/3, so I should actually distribute that through just to kind of clean it up a little bit. And so I've got a y over here, and then 4/3 x. And then when you take 4/3 of -9, you actually end up getting -12 if you multiply that out on your calculator. I'm going to flip-flop and rearrange, bring in my fancy f of -1. So the inverse function f of x is equal to 4/3 x minus 12. I'm not going to do 15 and 16, but if you could put your eyes on 15 and 16, slightly different kind of fraction. Slightly different. In fact, I would go ahead and I would be multiplying by 4 to clear that first. Kind of put this inside parentheses, so when you multiply by 4, it just sort of cancels. But you're not going to do that right away because you got to flip-flop your x's and y's. So, but that would be one of those steps I would do. I'd multiply by 4 first in number 15, and I'd multiply both sides by 5 first in 16 after I flip-flop my x and y's. And this is due at the end of the hour. Good luck.